A couple of announcements before we get started on notes. Announcement number one, check your grade. There are a lot of missing assignments for this hour. I believe, let's see, there are 92 missing assignments. So if you're missing an assignment, make sure you get those turned in. And that does not include the quiz. So if you're missing your quiz, make sure you get that in as well. So those 92 assignments are only assignments, not assessments. I did go through and mark anything that was not turned in, again, other than the quiz, as missing over break. So many grades changed. Again, if it's marked missing, you still have the opportunity to turn it in, and you still have the opportunity to turn it in for full credit. And you have that opportunity through, I believe, next week. And then next week when we start is when I believe our 4-week progress report grades are due. But once 4-week progress grades are in, then we will shut down the grade book for the previous assignments. So again, just a reminder, get those things turned in. Today we're going to talk about quadratic functions in intercept form and how to graph them. Just as a quick reminder, we had vertex form. I believe that was lesson 8.2. And for a parabola, that would be our function f of x, or you could write y equals a times the quantity x minus h squared plus k. We had standard form. That was lesson 8.3. And then today we're going to talk about intercept form. So, a couple of things we know based on the form, the vertex here would be the point HK. And the axis of symmetry would be x equals h. For standard form, and I'm going to draw a line so that I can separate the two. In standard form, let me start with the axis of symmetry. That'll be easier. The axis of symmetry is the opposite of b over 2a, and then the vertex, the opposite of b over 2a, and then whatever value we get when we plug that value into our function. The other thing that we know about when we're in standard form, we know what the y-intercept is. So that's helpful. With intercept form, we will know our X-intercepts right away. And then from there, we can find other things. All right. So it says using a graphing calculator, graph the following equation. Y equals x minus 4 times the quantity x plus 2. Label the x-intercepts, sketch the axis of symmetry. What relation do you see between the equation and the location of the x-intercepts? So we're going to graph that. I'm going to stop sharing for a second here so I can get the calculator out. Again, if you have your school issued Chromebook, it has the graphing calculator app on it, and it works exactly like the calculator that I'm using, which is nice. If you don't, there are ways, and they are in the Schoology page for this class. There are ways that you can get those, get a graphing calculator to use online. All right. So we're going to graph x minus 4, x plus 2. So I went to the y equals. I'm going to use the parentheses. X is right there next to the alpha button. Minus 4, x plus 2. And what I really want is I want to be in standard form, or I don't want, let me take that back. I want my graph to be in the standard window on my graphing calculator. So to do that, if you go to Zoom and option 6, and what that does is it goes from -10 to +10 in both the X and Y direction. All right, so there is the graph. And I think we can see it looks like the x-intercept there is at -2 and the other x-intercept is at 4. So let's go and put that into our packet. So there we go. I'm gonna put them in here as well. And some other things that we can find where it crosses the y-axis. So the y-intercept 1, 2, 3, 4, 5, 6, 7, 8. So I just counted on my y-axis down to the point where it crosses, and it crosses at y equals 8. Even though it didn't ask, I should say y equals -8. Even though it didn't ask, I'm going to put it in. And it looked like we have an axis of symmetry at x equals 1. Ooh, that's bad. bad drawing, Mr. Gingrich. So it looked like it went something like that. And there's our a sketch of what our graph maybe should look like. And then it asks, what relationship do you see between the equation and the location of the X-intercepts? So what do we have up here that would help us find our X-intercepts? You can go ahead and unmute and shout it out, or you could go in the chat and type in a response. So what I notice is I don't have -4 as my intercept. I have its opposite. And I don't have +2, I have its opposite. I'm going to change colors here quick. So it's very similar to our vertex form. The X coordinate is the opposite of what's in the parentheses. So the X-intercepts, I don't like that N. Have opposite signs from the intercept form. All right. So, some general facts about intercept form. Intercept form, the equation is going to be A times the quantity X minus P times the quantity X minus Q. And then our intercepts, our X-intercepts will be P0 and Q0. Kind of the interesting thing is once you know the X-intercepts, you can find the axis of symmetry. It's the average of the X-intercepts. Take P plus Q and divide by 2. And we can go back and check that if we wanted to with our previous example. Then our vertex, again, just like the other forms, that axis of symmetry is the X coordinate in our vertex, and the Y coordinate you find by plugging that value of X back into the original function. And then don't forget about A. A tells us if we have a positive value for A, that our graph is opening up. Negative value for A, it opens down. If the absolute value of A is greater than 1, we get a stretch, a narrower opening. And if the absolute value of A is between 0 and 1, we get a wider opening, just like we did with vertex form and standard form. So this has been the same for all the forms of quadratic functions. It's kind of nice to keep some things pretty consistent. All right. Graph the following quadratics and identify the X-intercepts, vertex, and axis of symmetry, and the Y-intercept. So all of this great stuff that we can find now with the different forms of the graph. X-intercept. Now we know the y-coordinate is going to be 0. And we know they're going to be opposites of what we have in the intercept form. So -1, +3. For the vertex, I'm going to do the vertex next. Axis of symmetry is a little bit easier. Take my values, my x values, or x coordinates for my x-intercept, and divide by 2. So this would be 2 divided by 2, or 1. Axis of symmetry is at 1. For my vertex, I know 1 is my x-coordinate. To find my y-coordinate, I plug 1 into my, for x, into my function, into my equation here. 1 plus 1, I know it's just after spring break, but hopefully we all know that 1 plus 1 is 2, and 1 minus 3 is -2. So -4 is where my vertex is, +1, -4. To find the y-intercept, you have a couple of options. One option is to take our equation and plug 0 in for x. And that will always work. There's it's not special just to intercept form. So if I plug 0 in for x, zero plus 1 is 1. 0 minus 3 is -3. So we cross our y-axis at -3. And we know we have a mirror image point on the other side of the vertex. Now, if you didn't want to do it that way, another thing we could do is use our pattern. In this case, there's no number written in front of the parentheses, so we just understand that A is 1. So from our vertex, we can go over 1, up 1, over 1, up 3 in both directions. Then I could go over 1 again and up 5. And if I had room, I could go over 1, up 7, and so on. And now we can sketch in our graph as best we can. So I should, I guess, 0, -3 would be my y-intercept. All right, let's try another one. The opposite of x plus 2, x plus 4. So remember that opposite isn't going to affect anything until we need to graph other points on the parabola. We still have our x-intercepts being the opposite value of what's in the parentheses. And I know it says vertex next, but I think axis of symmetry is easier to find next. Take -2 plus -4 and divide by 2. So what we're doing, it's the average, but it's the value right in the middle. So the value right in the middle of -4 and -2 is -3. Now to find the vertex, we'll plug -3 into our function. And here you see it's written in function notation. The previous example was in that y equals form. So we have that negative. And we're going to take -3 plus 2 and -3 plus 4. So you want to make sure you're keeping track of all of your negative signs. So we have a negative here. -3 plus 2 is -1. -3 plus 4 is +1. So we get the opposite of -1 times +1. Comes out as +1. The y-intercept, again, I'm going to plug 0 in for x. So this is my function at 0. I have the opposite of 0 plus 2, 0 plus 4. So I have the opposite of 2 times 4. 2 times 4 is 8. Its opposite would be -8. And I'd have another point on the other side. Again, if you like the step pattern, in this case, A is -1. So I go over 1, down 1, over 1, down 3, over 1, down 5, which puts me right there. And again, if I had room, I could go over 1, down 7, but I don't have enough room. Just a reminder on your homework, if you're asked to graph, you don't actually have to draw the parabola, just plot the points. Okay, and then I believe like on 8.2, you were asked to graph the parabola and the axis of symmetry, so you will need to draw in that dashed line, but just put the points in, and that's good enough. I should make sure that's easier to read. That is a -8. All right. Any questions so far? Again, don't be afraid if you have a question to speak up or put that question in the chat. All right, here we have y equals 2 times the quantity x minus 1 and x plus 1. So again, we have a value for a, but that's not going to affect our x-intercepts. In intercept form, the x-intercepts are only affected by what's in the parentheses. So I'm going to have 1, 0, and negative 1, 0. For my axis of symmetry, I take the x-coordinate of one y-intercept plus the x-coordinate of the other, divide by 2. And so I get 0 over 2, which is just x equals 0. It's right on the y-axis. For my vertex, I'm going to plug 0 in for x. So I get 2, 0 minus 1 is negative 1, 0 plus 1 is positive 1. 2 times negative 1 is negative 2. Negative 2 times 1 is still negative 2. So my y-coordinate is 0, negative 2. And because my vertex is at 0 and then my y value, that is also my y-intercept. As you can see, I already plugged 0 in for my x-coordinates. So there's really no work to do there. Finishing the graph, we do have that value of a, so we go over 1, up. Instead of 1 this time, we multiply by that 2, so over 1, up 2. Now we go over 1, instead of going up 3, we have to take 3 times 2. That is 6. 1, 2, 3, 4, 5, 6. And if we had room, we could go over 1, up 10 would be the next one, because we take 2 times 5. We just don't have room. So as you can see, this parabola is narrower opening. It doesn't open as wide as the last 2 examples we did. All right, a try now for you. Excellent. So go ahead and try this one. I'll give you a couple of minutes. If I can get my timer ready here. Here we go. So let me give you 3 minutes, and then we'll look at the answers. All right. Again, finding the X-intercepts. It's the opposite here, so it's not +3, it's -3. And it's not +5, it's -5. So -3, -5. You can probably already tell what the axis of symmetry is, but we'll use the formula. -3 plus -5 divided by 2. So the axis of symmetry is x equals -4. For the vertex, we're going to plug -4 in to our function. -4 plus 3 is -1. -4 plus 5 is +1. 1/2 times -1 is -1/2. -1/2 times +1 is -1/2. So we just have to estimate where that is. For the y-intercept, we're going to plug in 0 for x. And so we get 1/2 times 3 times 5. I think it's a little bit easier in this case to multiply 3 times 5 to get 15. And 15 times 1/2, well, that would be 15/2. For graphing, it's probably easier to actually find that as a decimal. And I know I usually put everything in fraction form, but just because graphing, sometimes it's easier to have a decimal rather than a fraction. You could also make it a mixed number, 7.5. All of those three values are actually the same. So we're going to go to 7.5. That's 4 away from the axis of symmetry, so we go 4 the opposite way. If we wanted to, we could use our step method, but remember we have that 1/2 we have to multiply by. So over 1 up 1 times 1/2, which is 1/2, over 1 up 3 times 1/2, that's 3/2. So 1, 1/2, 2/2, 3/2. Over 1 up 5/2, 1/2, 2/2, 3/2, 4/2, 5/2. And then the next one we have there already. So a little bit wider opening because of that 1/2. If you don't like intercept form, then we could convert from intercept form into standard form. That's what we're going to look at here. In order to do that, we're either going to have to use FOIL or the box method. And I'll do one of each. I'm going to do this one with FOIL. So we have x times x, that's x squared. X times 5, that's plus 5x. Minus 6 times x is minus 6x. And minus 6 times 5 is minus 30. I would then combine my like terms. X squared. 5x minus 6x is minus 1x. You don't have to put the 1 in there. I did because now I'm going to distribute, and it's going to be a little bit easier to distribute then. So distributing the 2, we get 2x squared minus 2x minus 60. So multiplying everything by 2. And that's the standard form of the equation X-intercept form that is 2 times x minus 6 times x plus 5. This one I'll use the box method to multiply out. Negative 1/2 times x plus 4 times x minus 6. And again, it doesn't matter which side you put the minus 6 and which side you put the x plus 4 on. I just chose to do it this way. We're going to fill in this box. X times x is x squared. X times 4 is a positive 4x. Negative 6 times x is a minus 6x. Negative 6 times positive 4 is minus 24. Combine our like terms. Negative 6x plus 4x is negative 2x. And this will go into my parentheses. And now I need to distribute that negative 1/2. And what might be helpful, multiplying by negative 1/2 is the same as dividing by negative 2. So negative 1/2 times x squared. Negative times a negative is a positive. And again, you could think of this as 1/2 times 2 or as 2 divided by 2. And again, with the last term, negative times a negative is a positive. 1/2 times 24 is 12, or half of 24 is 12, or 24 divided by 2 is 12. And there's that standard form. All right, one example for you to try. I'll give you a couple of minutes and then we'll come back and take a look at the answers. All right, I am going to do this one with FOIL again. So x times x is x squared. X times minus 8 is negative 8x. 7 times x is positive 7x. 7 times minus 8 is negative 56. Don't forget that negative that's out front, but I'm combining my like terms. Minus 8x plus 7x is minus x. And now when I distribute that negative, all I do is change my signs. So the x squared was positive, I put a negative in front of it. I had minus x, that becomes plus x. I had minus 56, that becomes plus 56. All right, have a wonderful day. Homework is posted.